we are going to finish talking about grammars today. At the end last time, I really just kind of left with a bunch of examples that I wanted to try out. So I hope you don't mind starting off with a bunch of examples. I don't know if you've completely forgot about how to do all this by now, but let's do these two together, refresh our memory, and then I got a bunch more for you all to try. We do have our homework back on schedule this week, so homework due tomorrow, which is about all of this stuff, and then our quiz on Friday. So your job is, in all cases, just make a grammar for this language. So the first one there, I believe we did this one last time. A to the n, b to the m, where m is greater than n. And the idea that you should have, remember, last time we had a few different kind of structured ways of thinking about this one, and one of them is balancing. I would think of this in terms of the number of n's, or the number of a's and b's are balanced in the sense that there's an equal number of them, but there's some extra b's. So my strategy would be make a grammar, first of all, as if there were an equal number of them, but then at the end, instead of just stopping, you make some extra b's at the end. That's my idea. So the standard grammar, which gives you an equal number of a's and b's, is that. S goes to ASB. This is the classical sort of balanced a's and b's. And ordinarily, if we wanted the a's to equal the b's, I would just say or epsilon, which ends it. But I don't want to do that because I want some extra b's. Anybody have an idea of how we can make that happen? Some extra b's? Yeah?
Maybe you could do could you do another definition for S, or would you need another non-terminal?
I think we need another non-terminal symbol.
So you could do T, I guess.
Okay.
And then you could do T goes to B. Or that's with an N and B. You go with BS. BT.
Yeah, I was going to say BT. Although I think BS would work actually, but it's too convoluted. This is easier. T goes to BT. So you can do this first one as much as you want, which will create equal number of A's and B's. And then at some point, you change over to a T. And the T, you do this one a bunch of times to create extra B's. We have to do something to make it stop. Typically, you would do or epsilon, which allows you to just end with nothing. Although I think in this case, you need to make sure there's at least one extra B. And so I'm going to say or B here to make it so that you have to do that. You have to get at least one B from the T's. All right? I like that. This is, in my opinion, the simplest way to go about doing that. Yeah?
So if you didn't have or B and you had or epsilon, then what you could do is just go to T and then go right to epsilon, right? And just skip over.
Yeah, right. So that would actually, the language of that would be this. M greater than or equal to N, right? If you went to epsilon here, then you could get no extra B's. Then they'd be the equal number of A's and B's. Yeah, great. How about this one? A to the N, B to the N, where N is even. This is a little tricky, maybe? I don't know. Actually, if you think about it in the right way, it's not very tricky at all. Anybody think about it in the right way? There's some kind of balancing here. We have the same number of A's as B's, but you got to make sure that that amount is always even. Yeah?
It would be like S to A, S, B.
Yeah, this is the cute and fairly simple approach. Making the N even, in order to make sure that number is even, you just build it two at a time, and then it's got to end up being even. We need a little something else? Or epsilon, yeah. Excellent. All right. Now, it didn't come up in either of these, but maybe I'll just refresh our memory. If you want a concatenation of two languages using a grammar, and you'll see actually, I'm going to give you a bunch to try. The first one, you should use a concatenation. But the strategy for that is you go S2, S1, S2, and then S1 goes to whatever, S2 goes to whatever, right? So the idea is if you already have a grammar for one thing and another grammar for another thing, you can stick them together by a concatenation by this. This kind of this is how you combine two grammars into a single grammar for the concatenation. Or you can also do A simple trick to get the union. If I have two different grammars and I want a language which is all things which are either this one or this one, that's what a union is. You just do the or. So it's like that. This is how you can combine two grammars together and get a language which represents the union of the two original languages. All right? Those are some other simple tricks. Actually, I think none of the examples that I'm about to ask you to do involve unions. The first one, like I said, is that you can think of in terms of a concatenation. All right, I got a bunch of examples. See what you think. In each case, make a context-free grammar. Context-free, remember, means the left side is just a single non-terminal symbol every time. Basically, any grammar you are likely to come up with will be context-free. Make a context-free grammar for each of these languages. How about, A to the N, B to the N, A to the M, B to the M, A to the N, B to the 3M. I'm going to walk around and see how you're doing with this. X followed by X reverse. Or X such that X equals X reverse. Those are similar but not the same language. Think about it. And then the last one, X such that. This last one is, in my opinion, quite hard, and I'm including it in there just as an example of one that looks maybe not so hard, but I think I have a fairly convoluted solution, and I'm not sure it's easier to do. I'm not sure it's possible to do any easier than my convoluted solution. But anyway, the first four I hope that you feel comfortable with once you think them through. I'll give you a few moments to get started, and then we'll walk around. We'll try these for a little bit, and then this is actually the end of what we're going to say about grammars, at least for now. So we're going to talk about something else. Feel free to talk to your friends.
This people. Oh, should I split it up? Two people can create it, but Oh, true, true, okay.
I would suggest think of this as
No, I don't.
Yeah, okay. Okay.
But the thing is, I don't know how many.
Yeah.
Yeah.
Unless we just do about this. Yeah, but then.
The problem is those two variables come together.
Yes, the
And
thing.
these are the schools are related.
That's the thing. You and the.
The reverse.
Oh.
Higher than
Because
that.
I was doing it to you over here.
because you use like this, you need to create water.
Oh, yes,
This
right.
is weird, because these are the same.
Problem is,
Yeah, like how would you go?
Yeah,
You're
like
gonna
how
go
would
to
you
a
go-
terminal and then come back from that.
Like, how would you assert these are the same number if there's,
Yeah.
if there is different
create a
groups?
whole lot.
You can't, you can be in the same concatenation.
Just
Just concatenation should work.
We would have to come to
I feel like it's a song.
Yeah.
Like I just can't figure out what else to do.
Okay.
You know, think of this not concatenation.
Okay.
But just what happens if you want zero b to
Okay.
Because it's only possible.
Thank you.
Unless I just do.
Yes.
Or maybe instead of this.
Yeah, it's like.
Okay, so we're supposed to
Because you need it.
Okay.
So it would actually be.
Alright.
Actually, this.
With the second one, because at first I was thinking like, doing something like that,
Yeah.
and then put
Yeah,
a
sure,
base
then
on
you
it.
like-
That's a good idea. I would say put S here. Because the these are the that many times.
Oh, yeah, so you can transact S and put T in.
And then you like.
I don't know how to do it.
And then you do this to make it.
Yeah, that's
So I would say that you do this a lot of times, and then you got some extra one.
Right.
So do like an or,
X,
but then.
X, V.
Oh, but then when,
I think
if
this
I
is
didn't,
regulars. Is it A, B?
You said E, S, S.
I don't know,
Maybe.
what did you
Yeah,
say?
just remember what it was.
T, like a word.
Yes, yes.
So,
Yeah, that's right.
I feel like it's about that. And then
Oh, no.
you discover that.
but it could be any of these two are right. Oh, yeah, so that's the S one, S two.
How do you know what S one, S two, S two? Where does that work?
Well, let's see, we have like A zero, actually, or continue. What is this or this? But I don't think this will apply. This one, we have A, B.
Like, if you wanna do A and then B then, you go S first,
So
so
we
S
have
one.
one with it.
The S in the middle, so that you put the X over here and get, you could get something that looks like.
It's like a center, it's in the center.
Yeah, exactly. Backward.
It's probably just A is B.
Yeah, that's.
Oh, it probably is the six months. It's probably like.
Yes, I agree. This
Because you
one.
can't, so you don't carry something.
I think this has an S.
Yeah, I don't get what that means, because you're probably not language B is specific.
It means that the, like ABBA is called, that is satisfied. It just means that that string is.
String word, string.
What is this?
What if you keep AS with BSA?
And then you, okay, you need to do this part and then this one, and then this A and then this one. But that percentage, don't you take that? Yeah. So yeah, so my first part is.
Reverse. That's right.
It seems too simple, but that's it. Well,
I did it, it's not really.
if you can try to do an example, especially if you want to make this.
Oh, yeah, should we go in? What's your AS?
Just to make sure.
Same on both sides.
But on this side it's the beginning, on that side it's the end. So it's those two.
Mhm.
That's the last.
Yeah, so try the next one.
Well, how do you trigger the middle? Because that makes sure the center is the same.
Yeah, because every time you call the center.
Oh, every time we call center, doing AA.
Yeah.
So you're back to back. Let's do it down.
Yeah.
Back to that. That's great.
Okay.
S.
Very almost.
Did you put it on Epsilon?
Isn't that good?
Next
Or
one.
they're the exact same? So Kelly.
Oh. I feel like this is a value.
I feel like it's good, but without. It would be the same. It's like, I feel like it's really subconscious.
Well, there's only, is there only A and B?
It's kind of like the same.
Oh, yeah. Oh.
Because if there's not, I don't know if
How's it going?
So I'm that's good.
Twenty-six.
Yeah, that's good. But for number.
Yeah, but assume it's.
And I'm on with such a fun.
They're almost the same.
Is it not the
Okay,
same?
yeah, see, now that works for that.
So something in this language would be something like A, B, A.
Why is it not the same?
Okay, now I see that.
Exactly.
Something, just here, something that's in this language, but not this language would be like A, B, A.
Okay, so if you have A, B, A,
That's in this.
but then you're still restricted to
Because there's that.
two to one side and two how you do it. What? Yeah, so that would work with the two.
All right, can we go over these? I know not everybody's done. I mean, maybe nobody's done. I didn't see anybody get the last one, but like I said, the last one is quite difficult. The first few I saw great answers for. This first one here is a concatenation of A to the M, B to the N, concatenated with A to the M. So the natural way to do this would be, first of all, it's a concatenation, and then the first part is my usual balanced A's and B's like that. And the second part is just a bunch of A's, so I'll go S2 to A, S2, or epsilon. I think pretty much everybody wrote something like that. I hope that's what you got, right? The next one is a little bit trickier. The next one maybe appears at first glance to be a concatenation, but it's not. You cannot, for instance, break it up like this and this, because the M at the end has to be related to the M at the beginning, so you can't split it up like that. It's really a balancing, and I saw most people ended up getting this eventually. You should have done something like S goes to B, S, B, B, B. This balances B on the beginning with 3 B's on the end, which will build out the two ends of it. And then at some point, you just need to finish with a bunch of A's in the middle. So I go or T, and then T goes to AT or epsilon. This is what I saw most people come up with for that one. Any questions about either of those? Those two are, I mean, not exactly easy, but more or less along the lines of ones we've done already. How about XXR? This one's a little tricky. The solution is kind of deceptively simple once you write it down. Anybody want to tell me what they said? Yeah.
S goes to ASA,
Uh-huh.
BSB, or
Yeah, great. So the idea here is there needs to be some kind of balancing, although it's not exactly balancing in the traditional sense that we usually talk about it. But this thing, if it begins with an A, it has to also end with an A, and if it begins with a B, it also has to end with a B. Did I say that right? I don't know. If it begins with an A, it also has to end with an A. If it begins with a B, it also has to begin with a B. So this also, you are thinking of this as building the string sort of from the middle out, and it's always keeping the stuff on the beginning equal to the stuff on the end. So that's how it works. The next one is almost the same. Can anyone explain in simple terms what is even the difference between those two things? They're both like palindrome type words, right? They are the same read forwards and backwards. Is there any difference? There is some. They are not the same. Yeah.
the second one can only have odd numbered palindromes, like odd numbered palindromes.
Yeah, I would say actually the second one is allowed to have odd length strings, but the first one is not. Like the first one has strings like A, B, followed by B, A, right? But the second one is allowed to have something like A, B, A, B, A, B, A, which is not, it doesn't actually have an even length. It has sort of an extra letter in the middle, right? So in fact, I would say the first one is a subset of the second one, right? The second one, it's the same idea, only the second one is allowed to have one last letter right in the middle. And when you think of it that way, it's actually, I think, not so hard to modify this one so that it's basically the same, but you allow it to have one extra letter in the middle. Can anyone say how you would do that? Yeah.
Or A or B.
Yeah, right. So this, instead of or epsilon there, or actually sort of in addition to that, I go ASA or BSB or epsilon or A or B. This allows you to create one extra letter in the middle if you want to, right? If that one in the middle is not necessary, but you can put it in if you want. Yeah?
Can't you do something like AB with this, which isn't, or...
No, AB is not, does not have, it's not in this set, because AB, the reverse of that is BA, and they're not equal. Yeah. Yeah, this set is really all the palindromic strings that are the same read forwards and backwards. This set is all the palindromic strings with even length. Yeah.
So would some of the strings be in both, but like the point is that there are some that aren't?
Yeah, right. Yeah, actually everything in this set is also in this set. The first one is a subset of the second one.
Okay.
But there are things in the second one that are not in the first one.
Okay.
Like that string I wrote there. All right. Okay, and this last one, the number of A's is the same as the number of B's. X such that X has the same number of A's and B's. Anybody think you got this one? I said that in my opinion. This is a hard one. The same number of A's and B's. Yeah?
I had one with two, A states.
Okay, two non-terminal symbols.
Yeah.
Is one of them called S?
S, yeah.
All right, I knew it.
So I had S to ASB or BSA, and then or ATA,
Okay.
and then or E, but then T was ATB or BTA or BSB.
Huh. Or epsilon? Or that's it?
I didn't have or epsilon because I figured if you get to T using ATA, you're gonna have to get two more B's. So.
Uh-huh. I like this idea. So this is some kind of balancing wherein every time you make an A, you balance at the same time by making a B. Here, it does allow for making two A's at a time. But yeah, like you said, this forces you to go down here, which eventually causes you to make two B's at a time, which should balance out the previous two A's at a time. I think this is not right, but I like the idea. I'm trying to think what I don't like, what's wrong about it.
You can't start and end with a B.
You cannot start and end with a B. Yeah, that's true. That's something. You can't start and end with a B. So BAAB is not allowed in this.
There's a couple things that I saw that weren't right, but
Yeah, this is a good attempt. Can I say I will put it? I'm tempted to do this, but I don't want to demean your attempt. It's a good attempt. I actually, like I said, I had to think about this for quite some time to come up with an answer that I was satisfied with. And as usual, these can be difficult to actually be convinced that they are correct. Anyway, here's my idea, and you can see if you agree. I intend for this example to be just a case in which there are some languages for which there is a context-free grammar, but it's actually really hard to come up with, even if you know some basic tricks about balancing. Even so, it can be hard to come up with these grammars, and this is what this example is meant to demonstrate. Here's my concept. I have S and two other non-terminals called A and B, and the S, of course, is something which will generate a string in which it has an equal number of A's and B's. So S will make some equal number of A's and B's, because that's the point of this whole thing, and S is where we start from, right? The A represents, A will make something with one extra A. That is, when you count up all the numbers of A's and B's, you get a string that has one extra A in it. And I think this is vaguely similar to his suggestion where sometimes you can make something that's not balanced, but then you have to compensate for that later on in the grammar. And B will generate strings which have one extra B. And so the idea is if a piece of my string ends up having an extra A, I need that to be balanced out by another piece which has an extra B. And then here's my actual grammar. That stuff is just like to help you understand the grammar. That's how you should interpret these symbols. But anyway, here's what I do. S goes to A, B, S. So that says my string might begin with an A, but if it does, it needs to be followed by a piece which has an extra B. That's to balance out the original A. And then maybe some other piece which is totally balanced, right? The S represents something which is fully balanced. Or it could look like BAS or epsilon, all right? So it might begin with an A, in which case it must have a piece which has an extra B in it, and then some other fully balanced pieces. Actually, now that I think of it, that big S may be unnecessary in these. No, it is. You'll see why in a moment. And then I have to say, how do we define the big A and the big B? The big A represents any string which has one extra A. So it could look like A, just A, that has one more A than B's. Or it could look like, here's a cute trick, BAA. That is, it starts with a B and then is followed by two pieces which have an extra A. That means that in total, this will end up having one extra A. And then the B I'm going to define similarly. B goes to, it'll be either a little b or a little a followed by two big B's. Yeah.
How does defining the capital A and B like that force you to do the extra A or B?
Yeah, so this capital A here, there are two alternatives. In the first alternative, it's just an A, so there is one more A than there are B's, because there's one A and zero B's, right? And in the other alternative, there are two parts which have an extra A and then one B. So in total, this has one more A than B's, because I have one B here and then two other pieces which have one more A than B. Yeah.
Okay.
If you wanted to really sort of prove that this is correct, you would use some kind of fancy induction, where I'm breaking the big string into smaller pieces. This is complicated, and this is not the kind of thing that I would expect you to come up with on a test or something. I just wanted to provide this as an example where sometimes it's complicated. Question? Yeah.
Wait, actually, I still think I had it. I was trying to put into words.
Some deep angst you're feeling. Yeah.
How do you start with an A, and then how would you end with an A too?
Start with an A and also end with an A. That is possible. Can we just try? Yeah, actually, that's why these S's are necessary. Like, if you wanted to start your string with an A, you would do this one first. But this A can result, this S again can result in something which ends with an A by going through this one and then making that A into an A and making this S into an epsilon. I don't know, that's too... I suggested that we try to derive this string. Let's just try that, just for fun. Let's derive A. I tried to come up with a very convoluted string in this language. A, B, A. This has 5 A's and 5 B's, so it should be derivable using this grammar. Let's see if we can do it. So I start with S. Lucky for us, actually, the structure of this grammar makes it pretty easy to tell like which step to do it at which time, because I want my string to begin with an A, and the only way that's going to happen is if I go S to ABS beginning. S goes to ABS, all right? And now that A is fixed there, my next step is, or my next letter that I want to see is a little b. So this big B, I'm going to turn into a little b. That's the only thing that actually will be valid at this point. So I'm going to go a little b s, right? It had to be that way. There's no other choice that you could have made to derive this string. All right, and now continuing from there, okay, just look at the next letter I want to see is a little b. So this S, I have to go this one. S goes to BAS. So it's AB and then B, big A, S. What's my next letter I want to see is a little b. That means this big A has to do this one, BAA. So it's A, B, 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 big A, followed by S, right? Getting there. Next, I want to see a little a, so that first of those two big A's is going to turn into a little a. So this becomes A, little b, little b, little b, little a. And then big A, big S. Right? Next letter I want to see in my answer is a little b, so that big A has to go to BAA. So it's A, B, 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 A, and now B, big A, S. Everybody with it so far? I'm up to here now. I'm trying to build this string one letter at a time. Next, I need to say a little a, which is this big A is just going to turn into a little a, and then I need to see another little a. So those two big A's, I'm going to turn them both into little a's. A, B, 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 A, B, little a, followed by S on the end. And then finally that big S, I guess I need to make BA, so this big S turns into a BAS. A, B, 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 A, B, A, and now B, A, S. That big A turns into a little a, and the big S turns into an epsilon, and that'll do it. A, B, A. Then the end. It works. It's not easy. All right. And actually, I will confess to you, this idea, I came up with this grammar, but actually it was not. This, in my opinion, when I write it this way, it seems like a complicated idea, and it seems to me like a complicated idea. I actually was able to come up with this grammar by building what's called a stack machine for this language, and then there's a procedure to convert a stack machine into a grammar. This language is easier to think of in terms of a stack machine, in my opinion. And then I converted that stack machine into a grammar, and this is what you get. All right. And funny I should mention it, because what I want to talk about next is stack machines. That's the next big topic. Like I said, this is we've basically said all that I want to say about grammars. And I want to move on to our next type of machine. Actually, sorry, I have another page on my notes here that I wanted to do. I do have one more thing to say about grammars, sorry. I just wanted to show everybody an example of a real-world grammar. I don't know if you've ever seen this, but just for fun, I thought we'd take a few moments to look at a real-world grammar for Python, everybody's favorite programming language. I don't know if that's your favorite, but at least it's a language that I know that everybody here allegedly is familiar with. Python has a grammar. Pretty much all programming languages, you can look up their documentation, and usually you'll be able to find the grammar for the language written out. And I thought it might be fun to look at. Here's a very simple Python program, and I want to look in the grammar and see how you can build this using the official grammar for Python. I'm going to, just to make it interesting here, I know this is not the most fancy way to write this program in Python, or this function. What? Why? All right. This is what a function definition in Python looks like. It has this special word def, and then the name of the function, and then parentheses with the parameters of the function in it, and then a colon, and then an indent, and then some stuff. Right? This is what a function looks like in Python. I want to see if we can look at the official Python grammar and find productions that allow you to make that in the grammar. So I looked this up. I hope it's still in my browser. I didn't check before class. All right, it's still there. Temporarily thinking, have I been looking at something entirely embarrassing in my browser between when I got ready for class and now? No. I would never look at something entirely embarrassing in my browser. This is a real world. So what I have over here is called the full grammar specification for Python. It says right there, this is the full Python grammar. If anybody asks you, if anyone wants to learn Python, this is the worst way possible to learn Python. If you want to know how to write a valid Python program, this will tell you, although, yeah, I think you agree with me, this is the worst way possible to learn how to do it. So what you see, the way that this grammar works is, instead of what we would usually write as an arrow, sorry, I can't do my dot on that side of the bar. What I would usually write as an arrow in the grammar is a colon. So at the top it says file, colon, and then some stuff. Other sort of shorthands they use in this grammar is, if you see something in brackets, the square brackets, that means it's optional. You can put it in there, but you're allowed to leave it out. So anyway, I'm looking for this function definition. And I happen to know, and all the non-terminals in the grammar have these big names to them. They're not like single letters, but they have big names. So I happen to know the non-terminal corresponding to function definitions is called, I believe, funcdef, something like that, which I'm looking for here. Here it is, function def raw. All right, I'm trying to put it at the top so you can see it. And what you see here is a function def raw. What it is it consists of literally the string def, which is what which you have to write here, followed by a space, which, I mean, is a space in the grammar, and then this capital name. Name is defined elsewhere in the grammar, and that is any kind of thing which is allowed as the name of a function in Python, or the name of a variable. I think there are some restrictions about what you're allowed to name them. And then after the name is the opening parentheses, that's this right here. And then it says an optional list of parameters in the brackets, that's the X. And then you see the closing parentheses, which is this, closing parentheses. And then you see optionally this arrow. I actually don't know, I'm not a super Python expert. I use Python a lot, but I don't know what does anybody know what? Apparently in Python you're allowed to put an arrow there and then some, I've never seen that in a, is it for higher order functions maybe? Or, yeah, I think this has something to do with a lambda type or specifying a function of functions or something, but anyway. Anyway, after you might have this arrow thing, which apparently does something, and then you have the colon. See, that's after that's this colon right here. All right? And then what follows the colon is some optional func type comment. I don't know what that means, but then it says block. So after this colon comes a block, and a block, I think, is down here. Block, there it is, consists of new line, all right, that's when you go down here, indent, everybody knows about Python, you got to indent, and then statements. So each of these lines is a statement. And then it says dedent. That means at the end of a Python block, you got to go back, unindent, which they call dedent, all right? So anyway, I thought this is kind of interesting to look at. You know, nobody who's interested in like writing Python code really cares about this grammar, but the grammar is important if you were trying to, well, if you wanted to write the Python compiler or the Python interpreter. The Python interpreter needs to understand how to look at a Python program and tell if it's legal or not. And this is how you tell if it's legal or not. So it's important for, not for ordinary programmers, ordinary Python programmers, but if you're trying to do something really fancy in terms of creating your own Python parser or something like that, then you would definitely want to have that official grammar document. Any thoughts about that? I think it's interesting. All right. Let's talk for about 5 minutes about stack machines. And this is our next major topic. Next major type of machines. Stack machines. A stack machine is something that is actually doesn't, the way that we write them down, they don't really look at all like DFAs or NFAs or regular expressions or grammars. Or, you know, they don't look a lot like anything that we've talked about. But it is a type of machine for accepting or rejecting strings. So it fits into the general structure of all the things we've been talking about so far. The stack machine, what is sort of useful about it, or its defining property, is it has a memory to it, organized in a stack. And if you've taken like a data structures class, this word stack it means what you think it means as far as the stack data structure. If you haven't, that's fine. It's not. We're not going to make a huge deal out of this. I will explain exactly what this means. But the idea is we start with an input string. And when the machine begins its computation, the stack, which is its memory, the stack is empty when you start. So we start with an input string and an empty stack. And just like a NFA, DFA, the stack machine reads the input string one letter at a time, left to right, and each time, rather than moving from one state to another on a diagram, it changes the stack. It can either add stuff into the stack or remove stuff from the stack. So we start with an input string and an empty stack. The machine reads the string one letter at a time. Left to right, it doesn't, go back and forth or whatever. It just reads one after another. The machine reads the string one letter at a time, and according to some kind of set of rules, each letter that it sees, it modifies the stack in a certain way. So the machine reads the string one letter at a time, and each letter read will modify the stack. All right. And the stack also consists of a string. So the stack, here's the idea for those who are unfamiliar with a stack. The stack is like an array in Python, or a list in Python. Is I'll say a list of letters. You could think of it as a string, I suppose, but we usually don't think of it as a string. It's a list of letters that are organized in a stack. I'm going to sort of write them like this, maybe A, B, C, D, in a stack, like piled up on top of one another. You imagine that this functions kind of like a stack of papers or a stack of books or something. And the machine is only allowed to access the thing on the top of the stack. This is the defining property of a stack, is that you cannot reach down into the stack and modify its middle or its bottom. You can only modify what's on the top. And the allowable operations are, you can throw away the thing on the top. So one way you could modify the stack is like that. I threw away the D, which was on the top. You are not allowed to throw away the thing on the bottom. You can only throw away on the top. And this is referred to, the cute name for this, what I just did there, is pop the D, all right? There are two operations you're allowed to do on a stack. One is pop, which is you just remove the thing on top and throw it away. Or you can put something new on top, and that's called push. So if I were to say push X, now the stack becomes this, A, B, C, X, all right? Those are the two allowable stack operations, pop and push. And this is the capability of the machine. It has one stack, and every time it reads a letter, it can pop or push something onto the stack. All right? You can immediately see why this is actually more capable, perhaps, than a DFA. A DFA can only have finitely many states, but actually, this machine is allowed to have a stack, and the stack could be as big as you want. The machine could be pushing things over and over onto the stack. It means actually there are more than finitely many, like there are infinitely many possible configurations that the stack could be in, versus only finitely many possible states for a DFA or NFA. So the stack machine actually, it's not, I will just say this as my closing remarks, it's not finite state, which should suggest that this is going to be more powerful than DFAs, because the stack, in theory, can have infinitely many different configurations, because it can grow as long as you want it to. All right, much more on that next time.